Sorry. See this rule, 4n plus 2 pi. N is the any integer number. Integer number means any 0, 1, 2, 3, 4. If you place 0 in case of the n, it gives calculation 2 pi electrons. If you place 1 in case of the n, then we get 4 into 1 plus 2 is equal to 6. Subsequently, we get 10, 14, 16, 18. If number of pi electron in the structure is equal to this number 2, 6, 10, 14, 18, then this will be the aromatic. Suppose we take an example benzene. Benzene contains 6 pi electrons. How? Each double bond contains 2 pi electrons. Benzene have the 3 pi electron. 1, 2, 3. It means 2 into 3, 6 pi electrons. If you see the rule of Haeckel, it contains 6 in this rule. That's why this is called as the aromatic structure. But in some cases, if I remove this obey cyclic ring, yes, it is cyclic ring. This is conjugation, yes, conjugation is present in between these 4 carbon. Planar structure, this is the, here it does not obey this rule, this structure. That's why it is non-aromatic, or is simply called as anti-aromatic structure. Mainly there are 3 types of aromaticity. Simply we call as aromatic structure, non-aromatic structure, and anti-aromatic structure. See one examples. Please answer. By solving the Haeckel rule, we are knowing to this, those ring contain 2, 6, 10, 14, 18 electron, that should be a aromatics. But some of the ring that do not contain this electron. Suppose see the example of this cyclobutene. Sorry, this is butene. Simply cyclic rings. Then assign our aromatic rules. There are 4 rules. First one is the cyclic structure. Yes, it is cyclic. Second rule is the presence of conjugated system. Yes, single bond, double bond, single bond, double bond. Second rule also obey. Third rule is the presence of planar structure. Yes, it is planar because each carbon is sp2 hybridized. Why it is sp2 hybridized? Because remember, presence of single bond is the sp3 hybridization. Presence of double bond is the sp2 hybridization. Presence of triple bond is the sp hybridization. And for planarity, we require sp2 hybridization. Third rule also obey, and next rule is the Haeckel rule. Place Haeckel rule in case of this structure, that is 4n plus 2 pi electrons. In case of this structure, there are 2 double bonds are present. One double bond contains 2 pi electron and 2 double bond contain 4 pi electrons. This in case of this, n is the four pi electrons. If you see this, 4 is not present in the Haeckel rules. That's why this structure is called as anti aromatic because it doesn't obey the Haeckel rules. Because to obey the Haeckel rule, ring always contain this number of electrons: 2, 6, 10, 14, 18. Those cyclic structure which doesn't contain this electron is called as anti-aromatic because these electrons obey the 4n pi electron rule. What is 4n pi electron rule? Simply, in case of Haeckel describes 4n plus 2 pi electron rule, but in case of anti-aromaticity, this structure obey 4n pi electron rule. If you place 0 in case of this, we get 0 electron. Then suppose we place 1 this case, we get 4 electron. Subsequently we get 8, 12, 16. It means this structure contains 4 electrons. That's why it is an anti-aromatic structure. This is the simple example that was in the any examination like GPAT. But in case of the GATE examination, there is a increase in the hard level of the questions. Let us see what are that hard examples. Suppose we take an example of any heterocyclic ring or the any 5-member ring. Suppose ring contains 5 members with heterocycles, means any heteroatom. That's why it is called a heterocyclic ring. This is the pyrrole. This is the furan. This is the thiophene. And this is the pyridine. Previously, we see the rules of the aromaticity. There are 4 rules in which second rule is the presence of conjugation. But in some cases, there is the presence of lone pair electron in case of the heterocyclic structure. In that case, rule lone pair electron also obey that rule. It means that we see this is the, suppose take an examples of the pyrrole. There are 4 rules. First one is the cyclic structure. Yes, it is cyclic. First rule is the obey. Second is the conjugation. Always remember, lone pair electron also contain a p orbital, as like this. This overlap is the pi electron present in the double bond. That's why lone pair also contributed in this structure. That's why there should be a conjugation between this double bond, single bond and lone pair electron. That's why this obeys the conjugation. Third, planar. Yes, pyrrole is the planar. Fourth one is the our Haeckel rule. We know very well Haeckel rule, that is 4n plus 2 pi electron. Those electrons containing 2, 6, 10, 14 and 18 pi electrons are the aromatic in nature. In case of the pyrrole, we calculate the electron first. This is the double bond, this is double bond. Each double bond contains 2 pi electrons, 2, 2, 4 and 2 lone pair electrons. That's why this structure contains 6 pi electrons. If you see the Haeckel rule that contains 6 pi electrons, it means it is the aromatic. In case of the oxygen, that is furan, furan contains 2 lone pair of electrons. But don't confuse, here there are 2 lone pair of electrons. Then these three rules are obeyed, that is cyclic in nature, conjugations, planar structure. But problem with Huckel rule, this is two double bonds, it contains 4 pi electron, and these 4 pi electrons, that is the 8, total is the 8 pi electron, but 8 pi electron is not present in the Huckel rule. It is called as anti-aromatic as per the rule, but Huckel describes those pi electrons which are present perpendicular to this pi electron is not calculated in the Huckel rule. That's why those lone pair of electron present outside the ring we doesn't calculate in the Huckel rule. That's why these furan obey the Huckel rule, because these 2 pi bonds and these 2 pi electrons means 6 electrons. These we are not calculated because these lone pair present outside the ring and they are perpendicular to the our pi bond, that is pi electron. That's why they do not overlap with the pi electron. That's why furan also are aromatic. In case of the thymine, same as furan, thymine also obeys same rule. But in case of the pyridine, pyridine also contains lone pair electron outside the ring. It means it also, this electron not also couples with the not conjugate with the ring. That's why these 3 double bond contains 6 pi electron. If you see the rule of Huckel, it contains the 6 pi electron, it means is aromatic. But this is the all, till now we see all the examples of aromatic. Now we will see the examples of anti-aromatic. Why the term anti-aromatic and non-aromatic terms? First, anti-aromatic. If you see the structure, simple, octatetratype. One, two, three, 4, 5, 6, 7, 8. That is 4 double bond. This, and apply the all rule of the aromaticity. First rule is the cyclic structure. Yes, it is cyclic. Second one is the, is it conjugated? Yes, it is conjugated because it contains alternate single and double bond, single bond, double bond. Third rule is the, is it planar? Yes, it is planar. Fourth rule is the Huckel's. Apply the Huckel rule for this structure. As this structure contains 4 pi bonds, 4 double bond. Each double bond contains 2 pi electron. 4 double bond contain 4 into 2 is equal to 8 pi electron. If you remember in the previous Huckel rule, those rings which are aromatic only contain 2, 6, 10, 14 and 18 pi electrons. But in this case, this structure contains 8 pi electrons. That's why it is not the aromatic. Though it is obey 3 rules, but not obey Huckel rule. That's why it is called as anti-aromatic. And next reason for its anti-aromaticity, because these structure when divided into 2 partitions, some of the electrons, non-electrons involved in this partition. That's why it is called as anti-aromatic. And let us see last example that is very difficult, and this is surely asked in the very GATE examination, because GATE is a very tough exam that asks very difficult question for 2 marks. See last example of the aromaticity. Sometimes they will ask about the structure like this. And sometimes they ask about this structure. this and this. Only difference is here is the cation present, here is the anion present in the structure. Always remember, anion contain 2 electrons, but cation contain no electron. 2 electron, that is called one lone pair electron. And these lone pair electrons are conjugated with this ring system. If this lone pair electron conjugated with this system, they are also calculated in the Huckel's rule. That's why if we compare with the aromatic rule, in case of these, positive charge contain no electron and negative charge, that is anion, contains the 2 electrons, that is one lone pair electron that are contributed in the, that is the structure of the cyclic. This structure, this causes the conjugation of the structure. If we apply the rule of Huckel, Huckel says those rings contain 2, 6, 10 and 14 pi electrons that obeys the aromaticity rule. If you apply the aromaticity rule for this contain 2 double bond, that is 2 double bond means one double bond contain 2 pi electron, 2 into 2, 4. 4 is not present in the Huckel's rule, that's why it is the anti-aromatic. This contain, these 2 double bonds contain 4 pi electron and this negative charge contain 2 electrons. 4 plus 2 is equal to 6 and the 6 is present in the aromatic, 6 is present in the Huckel's rule. That's why this structure is called as aromatic. And this question will ask in the 2013 GATE examinations. Thank you.